Alright, so in this video, we're going to be going over some more parametric derivative problems. Alright, this is video 3. If you haven't seen the first or second parametric derivative problem videos, definitely go check those out. So we have our first problem up on the board. We want to find where we would get a horizontal tangent for x equals t cubed minus 4t and y equals t squared minus 6. Okay, and this problem actually isn't that hard, okay? Because really, you just have to take a derivative here, and then you can compare them in the dy dx formula, right? So we do that, right? We get that our derivative with respect to time of x is going to be 3t squared minus 4. And dy dt is just going to be 2t. Okay? Now, we just plug that in to dy dx. Okay, and we want to find out where that is 0. So we get 2t over 3t squared minus 4. Now, don't just think, okay, I know it's automatically 0 because that's where the numerator becomes 0. Okay, and that's so we would have a horizontal tangent, right? Because horizontal tangents have a slope of 0. We need to make sure that the denominator is not 0 as well. Okay, because if the denominator is 0, then we have to do a limit, okay, and you'll see that in the next problem. But for this problem, right, it is just going to be t equals 0, because at t equals 0, this whole thing goes to 0, okay, because t squared, right, t squared, if you make that 0, this just becomes a negative 4 on the bottom, so you are going to get 0 by plugging in 0, okay? So that means that there will be a horizontal tangent at t equals 0. Alright, and that's basically it for this problem. Alright, so we have our next problem up on the board here. We want to find a vertical tangent this time, okay? And we have the graphs x equals cosine t and y equals cosine of 3t. So we got to do the same thing, right? We take our derivative with respect to time of x, getting negative sine of t. And then we're going to find dy dt, which is just going to be 3. We'll pull out that 3. And it's going to be times a negative sine of 3t, right? Which that's just negative 3 sine of 3t. Okay? Now, we got to plug this into dy dx. And we're going to end up with, well, these negatives are going to go away because we're putting them over each other. So this will be 3 sine of 3t over sine of t. So this sine of 3t over sine of t, right, that's just sine of 2t, right? We can use our, no, it's not. It's not at all. Okay, don't do that ever. Okay, this will not cancel out at all. So don't even think about it. Now, what do we do with this now? Well, we have to figure out where the denominator will be 0 and the numerator will not be 0, right? Because at that point we would get a vertical tangent. So where will sine of t be 0? Sine of t equals 0 at, well, t equals 0, right? Because sine of 0 is 0. And also at t equals pi, right? Because sine of pi is also 0. So what about sine of 3t equaling 0? Well, where does that equal 0? That's also going to equal 0 at t equals 0, because when you put in 0 here, you're still going to get sine of 0, which is 0. But what about pi? Well, here we get the sine of 3 pi, all right, which is basically the exact same thing as sine of pi. So it's still going to be 0 at t equals 0 and t equals pi. That means we have to set up a limit and figure out what the behavior is of this derivative as t approaches 0 and t approaches pi, okay? Because we don't know yet, all right? We know that it's going to be 0 over 0, okay? So we got to figure this out. Now, how we're going to do that is by taking this limit as t, we'll go t approaches 0 first, all right? We'll do t approaches 0, and that's going to be of our derivative here, of 3 sine of 3t over the sine of t. Now, we already know that if we plug in 0 here, this is just going to be 0 over 0. That means we need to do L'Hopital. All right, remember L'Hopital from Calc 1. All right, we do L'Hopital. That means we take the derivative of the top, the derivative of the bottom separately. Okay, this is not quotient rule. We'll get 9 cosine of 3t over cosine t. All right, and of course, oops, forgot the limit, right? We got to take the limit as t approaches 0. Well, now we can just do that, right? We can plug 0 in here, and we get 9 cosine of 0, right? That'll just become 0, which is just 9 over cosine of 0, which is 1. So we'll just end up with 9. It's equal to 9. Since 9 is not equal to 1 over 0 or anything over 0, we know that this is not going to be a vertical tangent, right? Now what about the limit as t approaches 0 of, well, actually, since we could actually, it's t approaches pi. The limit as t approaches pi of, well, we already know that if we put this down, right, 3 sine of 3t over sine of t, if we put in pi for that, we get a 0 over 0. If we take the derivative, we're still, we do L'Hopital, we still get this piece right here. So we might as well just put that down. 9 cosine of 3t over the cosine of t. All right, it just saves us a little bit of writing. Now, that is just going to end up being 9 again, because cosine of 3t, cosine of 3 pi, is just going to be, right, well, cosine of 3 pi is just going to be negative 1, all right? And the cosine of 3 pi, or sorry, the cosine of pi on the bottom, that's also negative 1. So you're going to get a negative 9 over negative 1, which is just 9. Okay, since that is also not equal to 1 over 0, we know that there are no vertical tangents. All right, and that's basically it. All right, so if you do get a 0 over 0 case, just take a limit. All right, see what happens. All right, and then you can kind of decide, okay, is there a vertical tangent or not? All right, and that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar, the explanation video for parametric derivatives, and the next video in the series. See you soon.